Unit 8, Video 4. In this video we will talk about a way of measuring concentration called molarity. This is a quantitative way of measuring how concentrated your solution is. We will actually be using something called a volumetric flask for the task, and we'll do a few labs where we use this special type of flask. Now this flask actually has a marking on the neck that corresponds exactly, in this case, to 250 milliliters. And this is to prepare solutions with an exact concentration. In chemistry, we actually use brackets around a compound to represent this idea of molarity. So for example, you will see oftentimes HCl in brackets, and it's referring to the molarity of HCl, to the concentration of HCl. The equation is actually pretty simple. You take the moles of your solute and divide it by the liters of total solution. Now moles of the solute, remember, is what you're dissolving. That's what the solute is. And the solution would be the total liters in your mixture, essentially. And it's usually shorthanded with M equals N over L. Remember, N we use to represent moles, L for liters. So if you have yourself a 3.0 M solution of NaOH, you actually read this as 3.0 molar sodium hydroxide solution. This means that you have 3 moles in every 1 liter of solution. Now 3 moles amounts to about 120 grams. The molar mass of sodium hydroxide is about 40 grams per mole. That's how we know we have 120 grams in a liter. Now oftentimes you don't have a whole liter. You could have just that volumetric flask that we saw earlier, and you may just have 250 milliliters in there. Which means you still have, if you were to have a liter, you'd have 3 moles. So you just have a quarter of that much. In this case, you just have 30 grams dissolved in there. But that ratio stays the same throughout the solution. And that's how it goes. So we're going to actually do some example problems with this. And the first example problem asks, you have a 35 ml aqueous solution that contains 8.5 grams of sodium chloride. What is the molarity? Now, what we need is the equation. Molarity is moles per liter. And we need to get moles. We'll get that from grams. We'll convert this into moles. And we can convert the milliliters into liters. To help you out, we can actually do that first. We got 35 mils, which then gets converted to liters. Milliliters on the bottom, liters on top. A liter is 1,000 milliliters. Effectively, you're moving the decimal place 3 times to the left, and you get this many liters. So our liters are 0.035. Our moles then is going to be 8.5 grams of sodium chloride. And then somebody go ahead and get me the molar mass of sodium chloride. Okay, exactly right. 5844 grams in 1 mole. And so if we do 8.5, so really what you're adding is 22.99 with 35.45. Exactly right. So we'll do 8.5 divided by 58.44, and you get yourself 0.1454 moles of your solute. And it's simply dividing the moles of the solute by the liters of solution. So your molarity now is simply 0.1454 divided by 0.035. So divide that number by 0.035. And you get yourself 4.16. Now we got 2 sig figs, so really 4.2. So 4.2. And customarily, you actually just put a big M at the back. So we've just created a 4.2 molar solution of salt. 4.2 molar salt solution, which is actually a pretty concentrated solution. That means if you had a liter of this solution, you had 4.2 moles in it. So simple as that. The next few questions, example problems, will simply make you go backwards. So this question asks, what's the molarity of a solution that contains, well, this is a practice problem. So this would be one you would practice on your own. This is practice problem 5. Pause the video and take a few minutes to try this on your own. Example problem 6 will have us go from milliliters and molarity into grams. So this is essentially the same thing backwards. We have 125 mils of a 0.55 molar HCl solution. How many grams of HCl does this solution contain? Again, we're just using the equation M is N over L. In this case, if we're asked for grams, then we would solve for moles. Moles is connected to grams. So you would rearrange this equation, simply multiply the liters to the other side. Your moles is molarity times liters. So our molarity is 0.55, or liters is 0.125. If you remove the M, you get yourself liters, that many liters. So your moles will be 0.55 multiplied by 0.125 to give you a fine value of 0.06875. Now this is moles of HCl. If we want grams, we simply convert moles to grams. 0.06875. And then you'll have to get the molar mass of hydrochloric acid. A mole should be 3646 grams, so simply multiply that by 3646. And you have yourself 2 sig figs, again, 2.5 grams of HCl. So when you pour out 125 mils of an acid that's 0.55 molar, you actually are pouring out 2.5 grams of HCl. Now with acids, this is really important because acids oftentimes come in not in a solid, but already an original solution. So in other words, you can't really weigh out 2.5 grams on the balance. The 2.5 grams comes from a solution. So acids come in solutions. In other words, they don't come as a powder. And that's why you would have to use molarity to determine how much of the acid you have, or how much of the acid you need. Alright, so we have example problem 6, practice problem 6. Go ahead and pause the video and try to do this on your own. And then we'll wrap up with this example problem. So you need 0.75 moles of potassium nitrate for a reaction. How many mils of a 6 molar solution should you measure out? Simply back to the molarity equation. Molarity is moles over liters. In this case, we are solving for liters. So rearrange the equation. Liters should be moles over molarity. You're simply moving the liters out this way, and then put molarity down here. And so your moles is 0.75, and your liters, or rather your molarity is 6.0. And you should get yourself so 60 divided by 6 is 10, and then you got 15 divided by 6, which is 2. You got 30 divided by 6, which is 5. If we do that correctly, then we got ourselves 0.125. Now this is liters, so we can convert this to milliliters, and we got ourselves 125 milliliters. Now technically we have 2 sig figs. I should have put an extra sig fig, but we got 2 sig figs, so you've got to get this up to 130 mils to follow significant figure rules. So 130 mils you would pour out. Excellent. And you can go ahead and pause the video and try problem 7. And then we will talk about making these actual solutions in the next video. In fact, actually, we have a little bit of time. Let's go ahead and talk about solution preparation. So it turns out there are 2 ways to prepare these solutions, and we'll actually do the extra calculations in the next video. So method 1 is the standard method, what everyone thinks of preparing a solution. You simply weigh out your solute on a balance, and then you use one of these volumetric flasks. Say we're using a 500 ml volumetric flask. What you do is you throw your solute in there after you've weighed it out. Say if you've calculated that you have to make yourself a 0.5 molar solution. Alright, you've got yourself 500 milliliters. So what you would do, you would first do a problem like we've done above, asking yourself, well, how many grams do I put into my solution if I'm going to have 500 mils of it? So you decide which flask you're using and then calculate the grams. You put the grams in there. You actually add some water to there. You can use one of these wash bottles. You can use a funnel if that's helpful, or you can go directly without it. And then you actually don't fill the bottle up to the top. You fill it about 3/4 of the way, and then you shake it. This would be a shaking motion or a swirling motion. And then at the end, you will actually fill it to the top. Now, you'll notice that it's lighter up here, and it's darker down here. That's because most of the solute is still down at the bottom. So usually cap this at the end and actually invert it a few times. And we'll demonstrate this in the class as a little demonstration of making a solution. So that's how you would make the solution of a certain molarity and a certain amount of it. Method 2 is actually by diluting a more concentrated solution. So in this case, what you would do, for example, acids, often come in a more concentrated form. Hydrochloric acid is famous. Hydrochloric acid actually comes in a 12 molar concentration, and then you would dilute that to whatever molarity you need. They don't actually ship for you a huge tank of caustic hydrochloric gas, hydrogen chloride gas, for you to poison half the science department. So they actually already make the solution for you. That's partly the safety reasons is why. So what you would do, and this is called the stock solution. This would be your 12 molar stock solution. And then you would simply take that stock solution and calculate how much you would need of it to dilute it. And we'll actually do a problem like that in the next video. And so you put that in there and then dilute it up with water. And, well, this is still the same one. You actually put it into the new flask. Dilute it up with water, shake it a little bit, and then fill it up to the mark, to the top with your solvent, in this case water. And then you got your new solution, your dilute solution. And that's the second way of doing it. It's actually diluting a concentrated solution. So we'll do one of each. We'll prepare solutions from scratch, and then we'll actually dilute some concentrated solutions, depending on the chemical that you are using. Right? This will then complete for us video 4 of Unit 8. We'll do video 5 next.